Okay guys, here we're going to apply some of the tangent line theorems that we learned in the last video. So let's start out here. We have a circle A, we have a line, and we notice that this is tangent because there's only one point. There's only one point where line CB intersects the circle A. So this is tangent. We want to find this angle ABC and line segment AC. Okay. So, first of all, we know that since this is a tangent line, we know that this is a right angle. Okay. And so we know, this we just kind of solved. This is 90 degrees. All right. Now AC, let's say that BC is 3. Okay. Then if BC is 3, then we know this is a right triangle. We can use Pythagorean Theorem. So let's see here. We can go up here to AC squared equals 3 squared plus 4 squared. All right. So AC squared equals 9 plus 16. So this equals 25 equals AC squared. So AC is going to equal 5. Okay. Moving on to this problem, we have something that looks like, I don't know, a head with a cone on it. But anyway, we want to find first of all x, and then DC and BD. Okay. So let's first focus on our x portion. All right. Here we know that again, here's a circle D. We have BA and BC. These are tangent because we can see these are only intersecting the circle at one point. Okay. So we know that if two tangent lines from the same point intersect a circle, then those tangent lines must be congruent. So we know that 2x minus 5 is equal to 4x minus 15. Okay. So 2x equals, it looks like 10. All right. 2x, and I had 15 equals 10, so x equals x equals 5. Okay. So looks like I've made a mistake here. Sorry. This should be not 2x minus 5. It should be 2x plus 5. So then that makes this, this should be 20. And then this would be 10. So x equals 10. And let me just verify my answer. So this is 10, which would be 25. And 40 minus 15 is 25. So this is 25. This is 25. So we're good. So this is 25. This is 10. Okay. So let me just put 25 here so I know. Okay. Now I want to find DC. Well, what does DC equal? We know that AD is a radius, CD is a radius, so DC is going to equal 10. All right, so that equals 10. So we know that is 10. And we want to find BD. Now, how do we do that? Well, before this chapter, we couldn't have done that, but we know that these are right angles. Okay. So we have right triangles here, all right? The hypotenuse is BD, okay? So we know that BD squared, let's call this y. So y squared equals, it looks like the sum of the legs squared, so 10 squared plus 25 squared. Okay, y squared equals 100 plus, if you don't know 25 squared, that's okay. So you just do 25 times 25 equals 5. Carry the 2, you get, let's see here, that's 10, so 12, 0, 0, 5, so that's 625. Okay, plus 625. So y is going to equal root 725. Okay. All right. In this problem, we have a circle. we have a line. We know that this is a radius. So we have AB. Let's say AB is a radius. Okay. So if AB is a radius, I want to know, is L tangent to circle A? Is L tangent to circle A? Okay, and why? Okay, we'll assume that B is on line L. So B is on line L. So this, in fact, is a tangent line. This is a tangent line because we have a radius, a tangent line. Or sorry, we have a radius and some line, and the radius intersects that line at a 90-degree angle. So the radius and this line L are perpendicular. The two lines are perpendicular. Therefore, this must be a tangent line. Okay. Moving on to our last problem. We have a circle O. It looks like we have a diameter here. Okay, so let's call this point C. So it looks like CB is a diameter. It also looks like we have AB. It looks like a tangent line. Okay, so A, again, a tangent line intercepts a curve at just one point. So A, it appears to be that point. And so we have this situation. Okay, we want to find X, which is CB. Okay, we want to find that. Well, since we know that this is a radius, this is a tangent line, we know this must be 90 degrees. All right. So we can use Pythagorean Theorem. 3 squared plus 5 squared equals, let's say this is y. Okay, that equals y squared. Okay. So this is 9 plus 25 equals y squared. So 34 equals y squared. So y is going to equal root 34. Okay, root 34 is between 5 and 6, closer to 6. It might be something like 5.8 or something like that. So this is about 5.8 or 5.7, 5.9, somewhere in that range. Okay, and we want to find what CB equals. So if this is root 34, we know that this is going to be 3. Why? Because OA is 3 and it's a radius. OC is a radius, so OC must be 3. Okay, so X is going to equal root 34 plus 3. Okay, you can leave your answer in exact form like that. That's no problem. Again, this is probably, it's between 5 and 6, closer to 6, so probably I would guess 5.8. I'm not exactly sure, but anyway, this would be, this number plus 3 would be the length of CB. Okay, hopefully this helped you guys understand how to use the theorems we learned in the last video. Thanks for watching.